Look, this is a messy looking quadratic, right? The highest power is going to be x squared, so we know that makes a parabola. Should look too... Alright, I don't want to think about this too hard. So it should be something like the... Oh, no, but it's still multiplied by... Yeah, I don't want to think about it anymore. It's a parabola, okay? It fails the one-to-one test, so this doesn't have an inverse unless you restrict the domain. So we're cutting off this part of the graph. We're only considering this part of the parabola because we're only considering where x is greater than or equal to 2. And if you do that, then you do pass the one-to-one test. It only crosses the graph at one place. So to find the inverse, we can do it now that we have this restriction. Get out of here. Alright, so we're going to switch x and y. This is like our y variable. We're going to replace it with x. Put a y in for x. And then to get y by itself, I'll get rid of this negative sign first. I'll divide a -1 from both sides. And now I need a square root. I have to square root both sides. So square root of -x, you might be thinking, no, can't do that. But you can. Because if you square root both sides, the square root of -x, you just want to have x values that are less than or equal to 0, right? So there's a restriction that just came up when we tried to find the inverse. Because you can't plug in any number bigger than 0. You can't plug in 1 or else you got the square root of -1. So we're going to subtract that 2 from both sides. We're going to divide -1 from both sides. So that just means we'll flip all these signs. And there's our inverse function with that restriction. To verify that it's an inverse, we have to plug our inverse function. So our inverse is 2 minus the square root of -x. It's an inverse if you can plug in your inverse function into the original function. So I'm plugging 2 minus the square root of -x into not the inverse, but into f of x. So f of x was all this jazz. Nice and yucky. So this is -2 minus, I got to put this in parentheses because I got to subtract the whole thing. I'll zoom out here in a second, recap what we're doing. Okay, I think I got it. F of x was -2 minus x, but this is all in parentheses squared, right? All I did was instead of x, I put our inverse, okay? And now this has to equal x when I fully simplify it, or else my magic trick has failed and we don't have an inverse. So to do that, the first thing I'm going to do is use the fact that the parentheses being squared. So I'm going to multiply the parentheses to itself. Actually, no, let's simplify inside first. So I'm going to distribute that minus sign. Okay, I just distribute that minus sign here. Oh, I'm not going to have to do a whole bunch of crappy parentheses stuff. So 2 minus 2 makes 0. So this is just now the square root of -x in here being squared. Look how it's simplified. Now we're squaring a square root, so get rid of the square root symbol. And a -x is a positive x. We've done it. So this is our inverse with that restriction that x is less than or equal to 0. I think there might need to be another restriction. So the other way of thinking about this, an inverse, the domain and range has been switched with the original function. So we should figure out what the range of this function was, and that should be the domain of the inverse function. Okay? So up here, if you were to graph this, which I didn't want to do by hand, but I guess I'm going to do now. Plug in x equals 2, you get out y equals 0. And you can use a graphing calculator if you want. If I plug in x equals 1, get y is -1. If I plug in x equals 3, that's -1. And I think we should be able to sketch the parabola from there. 2 comma 0, 1 comma -1. Oh, that's 3 comma -1. And here's 1 comma -1. So here's the parabola. The range is y equals 0 to y equals -infinity. So we're good. When we said that this has to be x is less than or equal to 0, we're all set because y had to be less than or equal to 0. We got the same thing. So this is our inverse function with that restriction that x is less than or equal to 0.